Assalamualaikum warahmatullahi wabarakatuh, and good day to the panels and the audience. My name is Nurul Hidayah Imaniah binti Hamdan, and I'm from Faculty of Mechanical Engineering. My supervisor is Dr. Natasha Ahmad Nawawi. Today, I will be presenting on my final year project proposal entitled the SINTERABILITY study on mechanical properties of eggshell-derived HA. Now, let's check out for the project summary. Calcium phosphate compounds, particularly hydroxyapatite HA, are a type of mineral that contains calcium and phosphorus, which can be extracted by recycling waste materials like eggshells through conventional sintering process. Although the conventional ball milling process has been reported to induce the risk of contamination that affects the product's purity, it is still being the preferred method used for mechanochemical activation purpose in producing HA. Moreover, this method is capable of mass production of highly crystalline HA powders. In this word, synthesized HA powder via the ball milling sintering method will be consolidated by uniaxial pressing and cold isostatic pressing, followed by sintering at 1100 to 1300 degrees Celsius. The sinterability of the powder will be evaluated in terms of its phase transformation and morphological evolution, and subsequently compared to the commercial HA powder ones. This analysis will be conducted by using X-ray diffraction and scanning electron microscope. Now, let's move to the introduction. The demand and need for artificial bone substitutes in the domains of medicine, dentistry, orthopedics, and spinal applications have increased over the past few decades. This is due to the numerous accidents, traumas, and bone deformities that have occurred depending on birth, age, and disease. Therefore, several factors including biocompatibility, osteogenic characteristic, bioactivity, and its mechanical function must be researched when a biomaterial is being considered for use in implants or bone graft in order to aid in patient healing. In general, calcium phosphate compounds are a type of mineral that contains calcium and phosphorus or phosphoric acid. It can be produced from human and animal bones, including eggshell. However, eggshell is frequently thrown away without further use, which has caused environmental and health issues. Therefore, in order to reduce eggshell waste, it can be diverted in a number of ways, including as a soil conditioner, fertilizer, animal feed additive, absorbent, calcium supplement, paper making material, and through recycling. All of these alternatives to landfilling have the potential to be more environmentally friendly ways to manage solid waste. Moreover, this research will explore the possibility of turning used eggshells into advantageous calcium phosphate to be utilized in biomaterials. This is also because eggshells waste is easily accessible, which reduces the cost of raw materials for the creation of synthetic biomaterials. In this literature review, there are two main keywords that will be focused on, which is first eggshell-derived HA, and the second one is sintering. Hydroxyapatite is one of the calcium phosphate compounds which has its own chemical formula as stated. HA is frequently used in biomedical and dental application due to its excellent biocompatibility, bioactivity, and osteoconductive characteristic. However, because of its low strength and poor hardness, the application of HA as a load-bearing biomaterial is constrained in comparison to cortical bone. Therefore, HA with better and desired properties might be manufactured based on the requirements of the application with correct development and processing. It can be retrieved by recycling waste materials like eggshells, coralline, bovine bones, fish bones, and oyster shells through a variety of processing techniques. Different processes are used to sinter HA. However, the conventional sintering process will be the primary focus of the processing method utilized to create HA. Sintering is a method that uses heat treatment to produce materials and components with specific densities. It is a common method for creating ceramic and powder metallurgy parts. The purpose of sintering is to make bioceramic denser and stronger mechanically. There are two categories of sintering process, which are liquid phase sintering and solid state sintering. Different sintering processes at different temperatures are shown in Figure 1. In addition, there are three consecutive stages to the sintering process, namely contact formation, shrinkage, and concerning. Figure 2 depicts a straightforward model that uses spherical particles to schematize every stage. In the first stage, net forms and expand between particles. Meanwhile, the pores are still open during the intermediate state. which creates the continuous phase, and it finishes when the pores pinch becomes separated. In the last stage, the isolated pores may totally vanish, producing a fully or nearly fully solid ceramide. Moreover, the parameters of sintering, which is sintering temperature, residence time, and pressure, influence density, porosity, grain size, and scaffold strength. So from studies, we know that although HA has various advantages, its application as a load-bearing biomaterial is constrained in comparison to cortical bone because of its low strength and poor hardness. The microstructure of HA, including the material's crystallinity and grain size, greatly influences both its mechanical strength and bioactivity. Therefore, by increasing the sintering temperature has allowed for further improvement of the mechanical properties of HA. Furthermore, the performance efficiency of the currently used processing procedure for generated calcium phosphate powder is affected since it has not yet produced nanoparticles with a regular, constant size and morphology. Additionally, the majority of the research that are currently accessible focus on the biological behavior or characterization of the synthesis HA powder rather than improving the mechanical properties of the HA powder. Therefore, the ball milling process determines the sinterability of eggshell-derived HA. The main objectives of the study are, first, to investigate the sinterability of eggshell-derived HA in terms of phase stability and morphology, and the second one is to compare the sinterability of the ball-milled eggshell-derived HA with the commercial HA powder. Now let's move to the next slide. The main scope and limitation of the project is to produce sinterability studies of HA ceramics through the use of waste eggshells as a calcium precursor. The sample of HA will be sintered at 1100 to 1300 degrees Celsius of temperatures. The milling process, which is ball milling as well as sintering process, is carried out to derive sample of HA and its mechanical properties. Both of these processes will be conducted at Advanced Manufacturing and Material Processing University Malaya and Advanced Material Laboratory University Technology Mara. Now, moving on to the methodology. First, the eggshell will be cleaned thoroughly with water to eliminate any remaining protein membrane layer and dried in a box oven overnight at 60 degrees Celsius. Next, a mortar and pestle will be used to crush the dried eggshells into fine powder before it is calcined at 700 degrees Celsius for 2 hours to burn off any remaining volatile substances. The calcined eggshell powder will then be mixed with a phosphate precursor, the calcium phosphate dehydrate, at a molar ratio of 1.67 for calcium to phosphorus ratio via mechanical activation, which is ball milling, with a milling time of 4 hours. Following that, the powder mixture will be dried at 60 degrees Celsius for 12 hours in the oven. The synthesized eggshell-derived HA powder will be compacted using a manual uniaxial pressing and cold isostatic pressing into circular disc samples. Subsequently, the green compacts will be subjected to cold isostatic pressing and sintering regimes at different temperatures via conventional sintering to investigate the microstructure and grain size evolution. Sintered samples will be ground using silicon carbide sandpaper and polished to a 1 micrometer mirror finish. The evaluation for both commercial and eggshell-derived HA powder will be carried out using several techniques. First, phase stability evaluation of the sintered HA dense ceramics will be evaluated using X-ray diffraction to observe any phase transformation with sintering temperature. Meanwhile, the morphological characterization will be evaluated using scanning electron micrograph. Last but not least, the expected result of the study is also being discussed. The sintered HA samples were evaluated in terms of phase stability, relative density, grain size, and Vickers hardness. Figure 3 shows the SEM image of hydroxyapatite that was sintered at different temperatures. It shows that the microstructure evolution of sintered HA at A 1000 degrees Celsius, B 1050 degrees Celsius, C 1100 degrees Celsius, D 1150 degrees Celsius, E 1200 degrees Celsius, and finally F 1250 degrees Celsius. That is all from me. Thank you for listening. If you have any question, please contact me.